This lesson is on linear equations. An equation of the form ax plus by equals c, where a, b, and c are constants, and a and b are not both zero, is called a linear equation, and its graph is a line. If the constant a equals 0, the equation represents a horizontal line. A horizontal line has slope 0. All of its points have the same y-coordinate, say d, so we can represent it by the equation y equals d. In the diagram, each of the points on that horizontal line have a y-coordinate of 1, so the equation of the line is y equals 1. If the constant b equals 0, the equation represents a vertical line. The slope of a vertical line is not defined since its calculation would involve divided by 0. There is 0 change in x from point to point. All of its points have the same x-coordinate, say d, so we can represent it by the equation x equals d. In the diagram, all of the points in that line have an x-coordinate of 1, so the equation of that line is x equals 1. If neither a nor b is 0, the line has a non-zero slope. If we solve for y in the equation, we get an equation in what's called the slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept. For example, in the equation 2x plus 3y equals 6, to solve for y, we would first subtract 2x from each side, which gives us 3y equals negative 2x plus 6. Then we would divide each side by 3, which would give us y equals negative 2/3 x plus 2. So this line has slope negative 2/3 because that's the coefficient of x, and the y-intercept is 2, that's the constant coefficient. It crosses the y-axis at 0, 2, and the slope of negative 2/3 means as x increases by 3, y decreases by 2. The activity that accompanies this lesson is titled Comparing Slopes. In each of the 3 problems, you're given 2 functions, and you are asked to graph those 2 functions on the same grid and then answer some questions about them. If you haven't already done so, you should work this activity first before continuing with this video. In problem A from the activity, the lines y equals 2x minus 3 and y equals 3x minus 3 are graphed. They have the same y-intercept, negative 3, but different slopes, 2 and 3. They both cross the y-axis at the point 0, negative 3, because that's the y-intercept, but the line with the slope of 3 rises faster than the line with the slope of 2, since the slope gives the rate of increase in y. The following 2 results were illustrated in the activity. First, 2 lines are parallel if either they have the same slope or both are vertical, in which case they do not have a slope. In problem B, the slope of both lines is 3, so they are parallel lines. The second result is that 2 lines are perpendicular if either one is vertical and the other is horizontal, such as the x and y axis, or each of their slopes is the negative of the reciprocal of the other slope. In the latter case, the product of the slopes will be negative 1, which provides a way of testing for perpendicular lines. In problem B, the slope of f of x equals negative 2x plus 6 is a negative 2. The slope of g of x equals 1/2 x plus 1 is 1/2. 1/2 is the negative of the reciprocal of negative 2. If we multiply those slopes, negative 2 times 1/2 is negative 2 over 2, or negative 1. As another example, the line from example 1 has slope negative 2/3. The negative reciprocal of a negative 2/3 is a positive 3/2. So a line which is perpendicular to this line would have slope 3/2. Multiplying these slopes gives 3/2 times negative 2/3 is negative 6 over 6, or negative 1. In the diagram, we see that a slope of negative 2/3 means as x increases by 3, y decreases by 2. That forms a right triangle. If we rotate that right triangle 90 degrees or by a right angle, making a perpendicular line, the 3 in the horizontal position becomes vertical. The 2 in the vertical position becomes horizontal. That's the reciprocal part. And the negative 2, because the line is going down 2, becomes a positive 2 because the line is going to the right 2. So that gives us the change in signs in the slope. Given two linear equations, there are three possibilities. 1. The lines intersect in a single point. The second possibility is that the lines are parallel and therefore do not intersect. The third possibility is both equations represent the same line, so they have infinitely many points in common, namely all of the points on that common line. A system of equations represents two or more equations. If there are values of the variables that satisfy all of the equations in the system, these are called the solutions to the system. With a pair of linear equations, any solutions would represent points that lie in both lines. If these are a pair of intersecting lines, the system would have exactly one solution, which would be the intersection point for those two lines. If these are a pair of parallel lines, the system would have no solution because the lines do not intersect. If the equations represent the same line, the system would have infinitely many solutions. In problem C from the activity, the graphs of the functions f of x equals negative 2x plus 6 and g of x equals 1/2 x plus 1 intersect at the point 2, 2. This represents the solution x equals 2 and y equals 2 to the system of two linear equations y equals negative 2x plus 6 and y equals 1/2 x plus 1. In the next lesson, we will discuss two methods for solving systems of equations, the substitution method and the elimination method. As an example, we can solve this system using the substitution method. By the first equation, y equals negative 2x plus 6. So if we substitute negative 2x plus 6 for y in the second equation, we have the equation negative 2x plus 6 equals 1/2 x plus 1. To solve for x, we first subtract 6 from each side of the equation, which gives us negative 2x equals 1/2 x minus 5. Next, we subtract 1/2 x from each side of the equation. So we have negative 2.5 x equals negative 5, or as an improper fraction, negative 5/2 x equals negative 5. To find x, we multiply each side of the equation by the reciprocal of negative 5/2, which is negative 2/5. So negative 2/5 times the negative 5/2 x equals negative 2/5 times negative 5. Simplifying gives us x equals 2. Once we know the x-coordinate is x equals 2, to find y, we can substitute x equals 2 into either equation. If we substitute it into the first equation, y equals negative 2x plus 6, so y is equal to negative 2 times 2 plus 6, or negative 4 plus 6, or 2. So the lines intersect at the point 2, 2, namely when x equals 2 and y equals 2.